Hi everyone, I wanted to talk to you about bearings and applications for bearings and actually applications for the law of sines. So this problem over here is pretty good because it helps us also know where the states are on the map and all of that. So let's read. A plane flies 500 kilometers with a bearing of north 43 degrees west from Florida to Illinois. So the first thing you should do when you have a bearings problem is to write the given, just summarize the given in your own words. So there is 500 kilometers north 43 degrees west, and that's from Florida to Illinois. Alright. The plane then flies 720 kilometers from Illinois to Massachusetts. So 720, and that's from Illinois to Massachusetts. Find the bearing of the flight from Illinois to Massachusetts if the bearing from Florida to Massachusetts is north 14 east. So that sentence actually gives us a given that right here, the bearing from Florida to Massachusetts is north 14 degrees east. So we'll write that part. And that's from Florida to Massachusetts. And now the question is asking us, what's the bearing from Illinois to Massachusetts? Alright, summarizing the given like that actually helps a lot because it helps us organize our thoughts on what to draw and what do we have and what we don't have. And notice that I kept everything aligned, like the states are aligned right here in this column, and then the distance, and then the bearings. And then I wrote what the question is asking, just in a simple form. Okay, let's take all of this given right here, and I'll put it right here so we don't get confused and have more space. Alright, let's draw the first thing. The first thing you should do with a bearings problem is actually start with a point. Definitely start with a point. So we start by the city that's we're heading from. So Florida to Illinois. That arrow represents that I'm starting Florida. So I'm going to say that Florida is right here. I'm going to represent it by a point. And on that point, I'm going to do a compass, and the compass actually helps me. Alright, so the compass actually helps me because I can do my my angles correctly. So now we need to look. Okay, so from Florida to Illinois. Well, where is Illinois? It's 500 kilometers away, and it's north 43 degrees west. So that line is between the north and the west, right? It starts from the north. See, that letter came first, so it starts from the north and it goes 43 degrees towards the west. It might reach the west, it might not reach the west. So I'm going to say I'm starting from the north and I'm going 43 degrees towards the west. So 43 degrees is something like that. It's a little bit less than 45. Okay, so I'm going to extend my line and I'm going to say that line is 500 kilometers. And now I reach Illinois. Agreed? Alright. Now, from Illinois to Massachusetts, that's 720. But see, they didn't give me a direction. It can be there, it can be here, it can be here. They didn't give me a direction, so I don't know where to put that. So I'm going to skip that one because I don't have a direction. So bearings problems, directions are very important. From Florida to Massachusetts, alright, so Massachusetts, we're going to see where does it a little bit. North 14 degrees east. So from Florida again. So I go from Florida, so I'm back here. And north 14 degrees east. So my line is between the north and the east, but I'm starting with the north because that letter came first. So they're telling me, starting from the north towards the east, I'm going 14 degrees. 14 degrees is a little bit smaller than that, but I'm going to draw it so that it's apparent to you. So, whoops. Let me try to erase what I did right here. Okay. Kind of having trouble with this one. I don't know what I actually did. It's not allowing me. Oh, there we go. Okay, well, that's nice. Now I learned something new, how to erase lines. Alright, so north 14 degrees east, something like that, where this is 14 degrees. Okay. Now, I know that they didn't give me a distance, so I don't know where Massachusetts is. It can be here, it can be here. We don't know where it is, really. Well, now we have to notice that from Illinois to Massachusetts, is that line, that's 720, it's something like it's somewhere here or here, we don't know. So that makes me realize that I'm in an ambiguous case situation. I don't know the direction for this side over here, and I don't know the length of this one, but all I know is that I have a side, and an angle. So that actually reminds me that I have an SSA situation. And we agreed in class that SSA is ambiguous. We don't know whether the triangle has an acute angle or an obtuse angle, so we don't know which one. We don't know if Massachusetts is up here or down here. On a map, maybe it will help us if we see a map that we realize that, I won't tell you where it is, but if you look at a map, you would know if Massachusetts is like higher than Illinois or actually lower and closer to Florida. But see, I won't tell you because I want you to figure it out first, and then maybe we can look at a map and realize that, yeah, we did it correctly. Alright, let's clean up our picture on the next slide and just memorize that we have a triangle. It's either an acute or an obtuse, and we have 720. It can be up here or down here, we don't know. And then we have 500, and we have this angle, which actually adds up. 43 plus 14 is 57. Alright, let's see what we can do. Okay, so now I want to talk to you about the two scenarios that we have. So as we realize, we have an SSA situation, and we're trying to figure out whether this angle is acute or obtuse. So we agreed that we can look at a map. Or actually, now I drew it kind of a clean for you to see, you can actually figure out that since this is 500, and we have a possibility that this is an obtuse angle, an obtuse angle, well, it should face the biggest side, right? So that angle should actually be facing the biggest side. But see, I have the 720, which is actually bigger than this side. So the 720 can't be facing an acute angle, and an obtuse angle is facing a side that's smaller than that. Because the biggest angle on the triangle should be facing the biggest side, and the smallest angle should be facing the smallest side, right? So if this is an obtuse, that's more than 90, it can't be facing a side that's smaller than 720, or actually smaller than the other two sides. Because imagine if this was a right angle triangle, that would be the hypotenuse, and the hypotenuse cannot be smaller than the other side. So we know right away when we have a clean picture like that, that this one over here is kind of rejected. But we'll see by actually also doing some calculations that it is rejected. So we can prove it more than one way. Also here, yes, Massachusetts is up there, and on the map you'll see that it's actually higher than Illinois, and it's kind of a northeast of Illinois. So this angle is 57. We figured that out because we added 14 and 43. Okay, now let's set up the law of sines. By setting up the law of sines, we can figure out that angle M right there. I'm going to call it angle M. So if we cross multiply, we can figure out that angle M is 35.62 degrees. We did that by cross multiplying. We figured out that sine M is 0.58241, and we arc sine that ratio over here to find this angle. Alright, so we can put that on our picture. So let's try a picture one more time, and obviously we're going to try this one because this one we can reject by showing some calculations. Actually, I want to show you those calculations. I want to show you why we can reject it. We can reject it because the other angle for M, the other possibility is 144.38. How did I figure that out? Well, because sine M is a positive ratio, that's a positive 0.58241, I know that sine is positive in quadrant 1 and in quadrant 2. So we figured out 35.62. Well, that's in quadrant 1 because it's between 0 and 90. Well, what happens when I put this angle in quadrant 2? So if I put this angle in quadrant 2, that 35.62, I have to give my answer in standard position. Well, to do that, I do 180 minus this angle. Because if you notice that 35.62 and this angle in standard position, they add up to 180. That's like half a circle right here. So if we do 180 minus 35.62, we get 44.38. Well, if we add that 144.38 to the 57, because now there are two angles in this triangle, we will get 201.38. 201.38 is definitely way too big for the triangle because all three angles in this triangle should add up to 180. So all angles in a triangle add up to 180, and when I add those two angles, I go over 180. I reach 201. And that's why we will reject this answer. Okay, now this is the picture that we have. We have this angle that was given to us, and we have this angle that we figured out using the law of sines. And since the triangle adds up. Okay, so this is the triangle that we have right now. We have this angle, which is 57. We figured that out, 43 plus 14. And we figured out this angle. And now since the triangle adds up to 180, we can figure out this one. Now, the bearing that they're asking for is from Illinois to Massachusetts. Now, that's this angle right here because it's north something east, and that something is this angle. It's starting from the north and going towards the east to reach that line that connects Illinois to Massachusetts. So, how can I figure out this one? Well, if you notice, this angle is alternate interior with this angle right here. Alternate interior angles are between two parallel lines, so if we see the north and south line in both situations, and those angles are alternate interior. So we can figure out this angle right here by adding 35.62 to this small one. Well, this small one is alternate interior with this angle right here. If you notice, there is also alternate interior angles between the north and south lines, and the transversal is this line right here. So it's right there, and this angle is actually 14 if we remember. So this must be 14. Therefore, if we add them up, 14 plus 35.62, we get 49.62. Therefore, our answer is north 49.62 degrees east, and that would be it. Thank you.